investing money.
Okay, this lesson, although it might sound intimidating, it's actually really applicable to your everyday life, especially if you're starting to invest or buy things of great value, or if you borrow money. So we're going to go through two types of interest. There's simple interest and compound interest, and there's a big difference on how the money builds. And so you want to know what lesson?
No, I got it.
Okay, just making sure. So, for example, like if you put money into a bank account, the bank will be borrowing some of your money while you're investing it. So, for that, I guess, courteousness of you, if that's even a word, if you're lending money to the bank, basically they're going to pay you a certain amount, okay, it's called interest, for allowing them to borrow your money. Similarly, if you borrow money from a bank, you will have to pay interest because you're borrowing from them. So it's just a fair trade for taking their money for a little bit or them taking your money for a little bit. So there's two types of interest that we're going to look at, simple interest and compound interest. The first one is quite simple. You can simply laugh. It's okay. No? Okay, it was that bad. Alright, so typically we're going to use simple interest for short-term investments, and basically what happens with simple interest is the initial amount at the beginning of the first year, it will always be the same in the second year, the third year. That initial amount will always be the same. Whereas later we're going to look at compound interest, and it's going to be compounded on top of one another. So the amount at the end of the first year will be actually the initial amount in the second year. And some of that might sound confusing right now, so we're going to do a few examples so you can see what it looks like. Okay, so let's just take a look at part A, simple interest. Pretend you're investing $500, which earns interest at a rate of 6% per year. How much interest would you earn in 1 year? So we're starting with $500. And all we have to do is multiply by 6%. And just note, with percents, we have to put them in decimal form. So 0.06. Okay, and if we calculate that, how much interest will you earn after the first year? $30. Okay, what if we're just looking at half the year? Then we're going to multiply our initial $500 times the interest rate, 6%, and then it's the years are in terms, or it's in terms of year, so we have to multiply by half a year. So even though it's 6 months, you wouldn't put 6, you would put it in terms of years. So if it's half a year, you have to put half, not 6. Okay, and if we calculate that, it should be half of what we got for 1 year, which is $15. Then if we calculate how much interest will be earned for just 1 month, we're going to multiply 500 times 0.06, and for 1 month, that's going to be 1 out of 12 months. And if you multiply that, $2.50. So it might seem like a little bit of money, but in a month, instead of having $500, you now have $502.50. So you're earning a little bit. Okay, what if you were investing a larger amount? Then the interest earned would be a lot larger too. Okay, so this is a small investment, small amount of time. Seems like a small amount of money, but in time it would be a lot of money. Okay, now if we're just pretending that our interest rate was R instead of 6%, we're just going to sub in R for where we put our interest rate before. Okay, and then we're going to replace the initial value of $500 with a P, which represents our principal amount. So the initial amount that you're going to be investing. So for 1 year, we would have P times R times 1 year. for half a year, it would be the principal. Okay, remember we had $500, so that's the initial amount. It'd be multiplied by the interest rate, just like we did times 0.06, which is R. And then we're going to multiply by half a year. Okay, remember it's always in terms of years, so if it's half a year, it's almost like 6 out of 12 months, or we could write it just as a half. And then the last one's asking, what if we're investing for T years? That would be the principal times the interest rate times T, which is the number of years. And that leads us to our simple interest formula, which is interest is equal to the principal times the interest rate times T number of years. So given that formula, we're just going to take a look at what Millie is investing. Excuse me. Okay, so Millie invests $2,350 at 7% per year for 6 months. We have to calculate after 6 months the simple interest on Millie's investment. Okay, so I equals PRT. Interest equals principal times interest rate times T in years. Let's just write down what we know. Principal, that's the initial investment. That's going to be $2,350. $50. Okay, the interest rate is 0.07, so we're at 7%. And T is 6 months, which in terms of a year is half a year. So 0.5, or you can put a half. So subbing into that formula, our interest will be equal to 2,350 times 0.07 times half a year. And if you could just give me a little help, what do we get? Perfect. $82.25. Okay, that's the interest earned after 6 months. So how are we going to calculate what she's earned in total? What's the value of her investment after 6 months? Good, you add them together. Okay, so it's going to be the principal plus the interest. So 2,350 plus 82.25. Okay, so what do we get there? Help me out.
432.25.
Perfect. Okay, so that's not bad after 6 months. Now, the second type of interest that we're mostly going to be talking about in this lesson is compound interest. And I mentioned it earlier, but the difference between simple and compound is simple interest at the beginning of each year, it's going to be that principal amount. Whereas compound interest, the amount at the end of the beginning of the second year is going to be different than the amount that you would have at the beginning of the first year. So the interest is compounding, which means the value that you're investing is increasing each year. Okay, we're going to do a little comparison on the next page. Let's pretend Booker's doing an investment here. And Booker wants to use simple interest. Nolan, he wants to use compound interest. So we're going to compare who's making the better investment. Okay, so both investment plans have an interest rate at 9%. Let's just read through. So we have Booker, he's doing a regular savings bond which pays simple interest at 9% per year, per annum. Okay, if you ever see per annum, that means per year. Okay, or annually, that means per year. Okay, and then Nolan, he's chosen to select a compound savings bond which pays interest at 9% per annum, PA per annum, compounded annually. Let's see what Booker's going to make first. Okay, so with simple interest, we have our initial amount of $5,000. Good savings, by the way. Okay, and the interest rate is 9%. So just to calculate the interest alone in 1 year, okay, remember interest is equal to PRT. So we're going to go 5,000 times our interest rate times 1 year. What do we get? $450. So in year 1, Booker's already gained $450 on his investment. Okay, for year 1, this is the calculation we used. For year 2, it's going to be 5,000 times 0.9 times 2 years. And we get 5,900. For year 3, what's your calculation? 5,000 times 0.09, and this time we're going to multiply by 3. So after 3 years, the end of 3 years, what do we make? $63.50. Do you guys notice what's the difference between each year? Is adding $450 each year. Okay, so if we kept adding $450 to the 8th year, we would get our total. Or we could just go, so keep adding $450 each year. Or we could go 5,000 times 0.09 times 8, and we get the total of his investment after the 8th year. 8,600. It's not bad. Gained $3,600. Happy with that? Okay, we'll see if Nolan's going to be happier. All right, introducing compound interest. Okay, so if we were to look at the end of the first year, basically the value of Nolan's bond would be the principal amount, which was 5,000, plus the interest, which is 5,000 times 0.09. Okay, if we were to factor out 5,000, like they've done, okay, 5,000 divided by 5,000 is 1, and the second term divided by 5,000 is just 0.09. If you add 1 plus 0.09, then we get 5,000 times 1.09. At the end of year 2, notice that instead of the initial principal being just $5,000, they're taking the amount from the end of year 1, and that is now the principal for the beginning of year 2. Okay, so the principal changed. Okay, then we're adding again. The interest would be on the principal times the interest rate. So if we factor out the initial principal of 5,000 times 1.09, then we're left with 1 plus the interest rate. Okay, and if we add this together, we get 1.09. 1.09 times 1.09 is 1.09 squared. So notice in the first year, we had 5,000 times 1.09. In the second, at the end of the second year, we had 5,000 times 1.09 squared. What are we going to have at the end of the third year? Okay, we have to the power of 1, to the power of 2. At the end of the third year, it's going to be 5,000 times 1.09 to the power of 3. So we're at the end of the third year. And yes, we could go through the same strategy that they're doing, but this is what we're getting to. Okay, it's just building the formula. I just want to talk about 1.09 for a second, and what you guys think that represents.
109%.
Okay. Essentially, yeah. And actually, I might hold off on that conversation until we get to the formula. Sorry, a little early. Let's just continue on, see what Nolan's going to earn, and then we'll talk about this 1.09 after. Okay, so once again, Nolan, he invested $5,000, but he's compounding annually. Okay, at the end of the first year, same thing as Booker. Okay, he only gained $450 in that first year. Okay, but what about in year 2? Can you guys help me out? Calculate 5,000 times 1.09 to the power of 2. Say that again?
I got 940.
Okay, might be a little bit off. Oh, no, yeah, you're right. Sorry, I was looking at the wrong one. So 5,940.5. Okay. All right, if we compare his year 2 to Nolan's year 2, he's up by $40.50. So far, he's already earning more. Okay, in the long run, let's see what happens. If we were to fast forward to year 8, what would my calculation be? 5,000 times 1.09 to the power of 8. Okay, when you calculate that, what do we get? 9,962. 81 cents. All right, who's earned more? Nolan. Good guy. Okay, he chose compound interest. He's earned a little bit more. Booker, you still did not bad though.
Yeah, that's right.
So after you graduate, or even now, maybe some of you are already investing. I know Nikita, he did some investing already to help his parents out just with some language. So he was the one doing the investing with them. So he knew a lot about this stuff already. You guys also will probably start investing soon too. And you want to make sure you choose the options that are going to give you the best outcome, right? You want the most earnings. So what we figured out is that Nolan earned a little bit more. And the reason why is because his earning, or his interest, was increasing exponentially. Okay, if you take a look at, let's just write this out again, Nolan for compound interest had 5,000 times 1.09, and basically to the power of the number of years that we were looking at. So if we have an exponent, what's the shape of our graph? It looks like this. So it's growing exponentially. Whereas if you think, and you can look back at the table of values for Booker, okay, the simple interest, we're increasing by what each time?
450.
Okay, yeah, exactly. We're increasing by $450 each time. I'm going to put T. Okay, and if we're increasing by a constant each year, it's kind of bringing you back to grade 10, but the graph is linear. Okay, if you're increasing by a constant amount every year, and the slope essentially is the same, then you're going to have a linear graph. So anytime you can increase exponentially, typically it's going to be a better payoff depending on the length of your investment, as well as I'm going to introduce some compound periods pretty soon. So a few more things to think about if you're making an investment. Okay, so we could go ahead and plot all the points from our table of values, but just saving some time, we have compound interest, it's exponential. We have simple interest, it's linear. Okay, the majority of this unit for this lesson is on compound interest. So this formula is going to be very important when we're solving the remainder of the questions in this lesson. Okay. Have you guys ever heard of investments where they're compounding semi-annually or quarterly or annually or bi-monthly? Okay. Those are all different compounding terms that you can sign up with if you go to a bank, and you just have to figure out, well, what might be best. And this formula is going to help you with calculating that. So going through the formula, let's talk about what everything means. So A will be the amount. That's the final amount that you're going to earn. Okay, or if you're borrowing money, what you're going to have to pay back. Okay, P is your principal amount. That's your initial amount that you're investing or borrowing. 1. So we were talking about it before when we had 1.09. You said it's 109%. You're pretty much right. 1 represents 100% of what the principal was initially, plus whatever the interest rate is. Okay, so it's 100 and something percent. Okay, to the power of n, which represents the number of compounding periods. Now just to help out, I'm going to tweak this formula a little bit, and it's going to really help us with solving questions later on. So can you guys please write A is equal to P times 1 plus I over n to the power of n times t. Okay, and then also could you put that t is the amount of time in years? And n will still be the number of compounding periods, but it's going to be per year, not the total. So just a heads up, on your formula sheet, you guys are given this formula here. But if you can remember this one, it's going to help you out a lot. So let's just practice using this formula with a few different scenarios. And we're going to see which scenario would be the best one for investment. So again, I'm just going to write this up top so you guys have it. Amount is equal to our principal investment, or the initial amount, times 1 plus interest rate over number of compounding periods per year, to the power of number of compounding periods per year times how many years. Okay, again, you can write that here. It's in the table, sorry. So who feels like investing? Okay, we'll go with Brett. He's itching his head, he's thinking about it. Okay, so Brett's going to invest $1,000. He's thinking about doing that for 5 years. Okay, the annual interest rate is 6%. We got to complete the table of values to figure out what is his final amount after the 5 years. Okay, he's going to invest annually, or he's going to look at a few options. So he's going to look at what if he compounds annually, semi-annually, quarterly, or monthly. So if we are compounding annually, what does annually mean? Per year. Okay, so the number of compounding periods per year will just be 1. And if we are compounding for 5 years, the total number of compounding periods will be annually times 5 years. So we get 5. So this in our formula is pretty much like our n, and this together is like n times t. The interest rate per compounding period in this case, the interest rate is 6%, so we're going to go 0.06, and we're going to divide by the number of compounding periods. In this case, it's just 1, so it would be equal to 0.06. So we can say that this is our I divided by n. And then we just plug in what we know. So the amount will equal the $1,000 that you're initially investing times 1 plus 0.06 divided by 1. I wouldn't actually need to show the divided by 1, but just for purpose that you get used to the formula, I'm going to show that. Okay, all to the power of 1 times 5. And if we calculate that, we get 1.06 to the power of 5 times 1,000. So I just added what was inside the brackets, and I'm raising it to the power of 1 times 5, so 5, and then multiply it by 1,000. If you guys could just help me out with the calculations as we go, just if you know it, let me know.
1,338.
1,338.
38. 23 cents.
23 cents. Okay. Good. Okay, so that's a pretty good investment. You're making $338.23 after 5 years. Let's see if we can do better. What if we compounded semi-annually? So how many times a year is semi-annually? 2. Okay, so your N is 2. Total number of compounding periods will be how many times you're compounding per year times the number of years. So we have 10 total compounding periods. The interest rate will be per compounding period. So we have 0.06 divided by 2, or 0.03. And our formula will be amount equals 1,000 times 1 plus 0.06 divided by 2 to the power of 2 times 5. So we're going to calculate 1.03 to the power of 10 multiplied by 1,000. Always do your exponent first. So $1,343.92. So if Brett invests with a compound interest that's taken semi-annually, he's earning a little bit more. Do you get the same amount?
For which one?
The second one?
We're
Okay.
on the third one.
Okay, just making sure. Okay, quarterly, that would be 4 compound periods per year. Nolan, you with us? Okay, good. Okay, total number would be 4 compounding periods times total number of years. So 4 times 5, there's 20 compound periods in total over the 5 years. So our interest will be compounded at 0.06 divided by 4 periods per year. Okay. So if we calculate, we get the amount is equal to 1,000 times 1 plus 0.06 divided by 4 to the power of 4 times 5. Now keep in mind, if you want to simplify things before you calculate, go for it. For example, 4 times 5, you could put that as 20. Or you could figure out what's inside the brackets first, raise it to the power of 20, then multiply by 1,000. So after 5 years, if we compound quarterly, the amount is $1,346.86. Earning a little bit more. Now let's try monthly. Hopefully we can go a bit faster. So monthly, that's 12 times in a year. Total number of compound periods will be 12 times the 5 years. So 60 compound periods in total. The interest rate will be 0.06 divided by 12. So when we calculate this, we get 1,000 times 1 plus 0.06 divided by 12 to the power of 12 times 5. And final our value would be $1,348.85. So if you go into the bank, which choice are you going to choose? Monthly. best investment plan in this case? So keeping with the formula where we're solving for our amount, let's just try this investment. So we have a $7,000 investment, and we're investing in a 6-year GIC compounded quarterly at a rate of 5% per annum. We have to find the value of the investment at the end of the term. Okay, so the $7,000, that's our P. That's the principal amount on our investment, or the initial amount. Okay, the 5%, that's going to be our interest rate. So 0.05. And what's your N? Good. Okay, just checking. So compounded quarterly, that's your N. And then we're also going to introduce a T. T stands for number of years, so that's going to be 6 years. The amount is what we're looking for. So now that we have everything we need to know, we just have to plug it into the formula, where amount is equal to principal times 1 plus our interest rate divided by number of compound periods, all to the power of the number of compound periods times the number of years. So let's just sub in our information. We get 7,000 times 1 plus interest rate 0.05 divided by 4 to the power of 4 times 6. Emily, what'd you get?
I got 9,431.47.
Good, perfect. I shortened it a bit. Yeah. Okay, I'm gonna let you guys try. Actually, no, I'll help you out with this one. I'll let you try the very last one on your own. Okay, Christine invested $2,500 for 4 years, compounded semi-annually. She received $843.26 of interest. What was the annual rate of interest? So in this case, let's just check out what is her initial investment? P. 2,500. Okay, they're asking us what was the annual interest rate, so that's my question mark. So I'm going to be solving for. N stands for what you're compounding annually, so in this case we're compounding semi-annually, so that N is equal to 2. How many years? 4 years, so that's your T. And the amount, they've told us a hint about it, but we have to do a little calculation. It said that you received $843.26 interest. So what was the final amount after her investment, after 4 years?
3,340.
How'd you calculate that? What'd you do?
I have it done.
You good. Okay, so you're gonna add 2,500 plus the interest earned, which is $843.26. And then you're gonna plug it into your lovely formula. You might as well write it here. Okay, so if you add 2,500 with $843.26, you should get $3,343.26. That's going to be equal to our principal, 2,500, times 1 plus our interest. Oh, don't know that, so that's just going to be left as an I. Our n is a 2. And we're putting that to the power of 2 times, sorry, I forgot to write that on the side. T is equal to 4. So to the power of 2 times 4. So this is just a matter of rearranging to solve for I now. So first we're going to divide by 2,500 to cancel that out on the right hand side. Whatever you do to one side of the equation, we do to the other. I might just use a lot of space to show this one, okay? So we have $3,343.26 divided by 2,500. That equals 1 plus interest over 2 to the power of 8. How can I get rid of the power 8? I can take the 8th root, or I can raise the power of 1/8. It doesn't matter which way you do it. You can do the 8th root, or you can do to the power of 1/8. Because whenever you have a power to a power, you have to multiply. And what's going to happen to the 8th? It goes away. Similarly, if you took the 8th root to something that had to the power of 8, it becomes this, and the 8's cancel out. Okay, they're opposite operations. So if I'm taking the 8th root on the one side, I also have to take the 8th root on the other side. I'm going to give you a little caution or warning. If you evaluate this, what the value of this is right now, do not round your answer till the very end. Okay? So I'm just going to hold all the digits as is. And you guys maybe can just watch along and do the final calculation at the end. So we have this to the power of 1/8 equals 1 plus interest over 2. What's my next step? Subtract 1. So I'm going to subtract 1 to this side. I subtract 1, that cancels out. And then I have to multiply by 2. You guys okay if I erase this? Okay, now if I'm solving for the I, and I have 2 in the denominator, I have to multiply by 2 on both sides. So I have 2 multiplied by all of this. So that's a lot to put in your calculator, and just to help you with that, first we're going to divide 3,343.26 divided by 2,500. Press enter. Raise it to the power of 1/8. Press enter. Subtract 1, press enter. Then multiply it by 2, press enter. That's probably the easiest way to do it so that you don't make any silly mistakes on your calculator. And after we're all said and done, what do you guys get? Okay, so you should get 0.074, which is equivalent to 7.4%. If you didn't get 0.074, you might want to try your calculation again, or just put your hand up, I can come help you. Or ask a friend. Phone a friend. How are we finding this so far?
Awesome.
I love the enthusiasm. Everyone likes to invest money. Or make money, I suppose. Can I erase this? Okay, now we're going to get to a couple questions where our unknown is not necessarily just a matter of rearranging the equation simply. We're going to have to throw in our logarithms and our knowledge on how to go from exponential to logarithmic form. Okay, Barbara, she's investing $8,000 in an account which pays compound interest at 6% per annum, compounded monthly. Let's just forget about the second sentence. Let's just record what we know. So the investment, $8,000, that's our P. Okay, compound interest at 6%, so that's our I, our interest rate, 0.06. Compounded monthly, what's our N? Okay, that's gonna be 12. And she's investing for how many years?
We don't know.
Don't know. Okay. Well, what's A? Oh, we gotta read the next sentence. Okay, how long would it take in years and months for her investment to double in value? Okay, so when it's asking you the length of time, that's our T. Okay, and they're telling us this hint that it's doubling. So that's gonna help us with our amount. So we have 2 times 8,000. Or 16,000. So let's plug what we know into our formula. Amount equals our principal times 1. Tell me what it is. Plus
Plus 0.00.
interest divided by
N to the NT.
number of compound periods to the power of NT. The reason why I was asking is because this isn't the formula you're given. So you have to remember to divide by N and multiply by T. Okay? So I tweaked it a bit so that it makes the calculations easier.
Is this only when you have time?
Pardon?
That you do that?
We've been using this formula for every single question.
I know, but the other one doesn't have T in it, so it's only you only use it when.
But if you don't have time,
You just use this 100% of the time.
Pretty much. Yeah. Joe's, I would just remember this one and use it.
Yeah, but
Oh, you mean for simple interest?
yeah, like. Yeah, like when would you use the other one?
So a big hint when to use this formula is it tells you you are using compound interest. If you're using simple interest, it won't say compound. It will likely say simple.
and you use the original one, or is it a different one?
Simple interest, you calculate as interest equals principal times interest rate times number of years.
Oh, so.
Okay, so if it says compound, we use this formula. If it says simple, we use this one, and then we add it to our initial amount.
Okay, thanks.
Alrighty, so let's up in what we know. The amount is 16,000. Principal is 8,000. So we have 1 plus our interest rate, 0.06 divided by 12 compound periods to the power of 12 times t time. We've got to solve for t. So let's clean things up a little bit. Okay, 16,000 divided by 8,000, we get 2. And what do we get here? 1 point. Am I off on that or right?
Yep, that's right.
Okay, good. To the power of 12t. So we've cleaned things up a little bit. What do we do when we have to solve for an unknown that's an exponent?
Log.
Yeah, we use our logs. So we're going to put this into logarithmic form. A couple ways we can do it, but I'll just put it into logarithmic form. Okay, so we have log of our base, 1.005. Argument 2, that's going to equal the exponent 12t. So our base of the exponent is our base of our logarithm, the argument, and we're trying to figure out what this exponent is, which is why it's equal to the logarithm. So now to calculate, do you guys remember the change of base identity? How I could evaluate this in my calculator?
Log base 10 2 over log.
Good, I use a base 10, so I can write it as log 2 divided by log 1.005. What does that equal? So if we calculate just the left-hand side,
138.9. Oh wait, yeah.
138 point,
9757.
okay, so we want to keep those decimals in there. That's equal to 12t. To solve for t, we just now divide by 12. So whatever you have in your calculator right now, 138.9777. Divide that value now by 12. And what do we get
11.58.
with a bunch of decimals?
131. Yeah.
Okay, there's lots of decimals. Let's just go back to the initial question. Yes, we've solved for t, but they want the time in years and months. So the 11, that represents years. And we have to figure out how many months by multiplying the decimal. Okay, so to do that, we're going to go 0.5813, and whatever those decimals are, we multiply by 12, and how many months do we get?
6.97.
How many?
6.97.
Okay, so 7 months. Alright, so we have 11 years, 7 months.
Oh, I get it.
So before you guys start investing money, what's likely to happen is you guys will probably borrow money first. Unless you're lucky and you have a good job, or maybe your parents help you out, start an investment for you. But in Andrea's case, she's gonna borrow $7,500 from her parents, and her parents have thought they want to teach her a little bit about investing and borrowing, so they're gonna charge her an interest rate of 4%, and they're gonna compound it quarterly. When she pays off the loan, there's an interest amount of $785 that she has to pay on top of the initial $7,500. And you guys have to calculate what was the length of the loan. I'm going to give you a hint. It's pretty much mirrored to what we did in this question. So this is your opportunity to practice now. So I want you guys to solve this last question on your own.